f of s, which in this case will be square root of x. Okay? Now imagine, what I'm going to do is I'm going to rotate this figure about the x-axis. Okay? So in this case, imagine we have this, let's see here, this 0.1. Okay. And we say let's go here, here. Okay. Whoa. So you just observe right now it's rotating the entire function about the x-axis such that a cone is going to be formed. Do you see that?
Yes.
Well, that's enough. Okay. Okay, so you get the idea. So in this case, for example, sorry. Put it again.
¿Es un programa propio o está en internet?
Yo llevo
Una película.
Do you ever allow you to see this kind of animations? Gracias. Anyway, the idea then, you observe the figure is that, how do I obtain that figure? Simple. In this case, observe, if I were to take a rectangle with dx and f of x, how do I obtain the volume? Simple. Every single rectangle is going to be rotated about the x-axis. So in this case, what you get at the end is basically something like a disc. Something like this. Certain width and this. Okay? Every single rectangle that you have forms a disc. So if you want to obtain the real volume of that figure of solar revolution, you need to calculate the sum of the volumes of each individual disc that is formed. But the question here is, okay, how do I get the volume of each individual disc? What figure is this? If it's a disc, what kind of figure is that?
Circle.
Not circle. In 3D. Sphere, no. A cylinder. It's a cylinder. Una esfera es redonda, tal cual, pero esta no es una esfera, es un cilindro, porque un cilindro aportado, obviamente, pero es un cilindro, en este caso con una cara circular y una cierta anchura. Okay, what's the volume of a cylinder? Area of the base times the height. So in this particular case, area of the base will be the circular face of the cylinder. So it will be pi times the square radius times the height. Okay? But in this disc, this is going to be the base, and this is going to be the height. The question is, by using this as a reference, this dx represents what?
The height.
The height, exactly. So now, by using this, the volume is going to be pi times dx, which is the height, times what? The radius. What's the radius of this? Exactly. This f of x is this f of x. So if I want to put in the formula, it will be f of x to the square. Okay? That's the volume of a single disk. If I want to obtain all of the disks together, I will need to add all of them. But we're not going to use Riemann sums here anymore. No, we're going to use an integral. Okay, we're going to use an integral now. The volume of a solid of revolution, then it's going to be pi, which is a coefficient, a constant, it's always pi, times the integral. From where to where? Remember that the Riemann sums always starts at a certain point and ends at a certain point. Certain region. So it's going to be the integral from A to B of what? Of this. F of x to the square times dx. This is what we call the disk method.
So pi times the function.
Pi times the integral of the square of the function times dx. This is the radius of the square. This is the height of each individual disk, which is the length of the subinterval. Okay. In this case, is respect to x. If it was respect to y, then the formula is going to be something similar. The volume pi from A to B of f of y to the square times dy. This is respect to y. How do I know it's going to be respect to x and respect to y? The problem tells you that, but also because the radius of each individual disk is perpendicular to the rotation axis. In this case, for example, this radius is perpendicular to the x-axis. If it was, for example, respect to y, this rectangle will be something like this, where you have dy, you have f of y, and the radius, which is f of y, is perpendicular to the y-axis. Okay? So it depends on the question of the problem. The problem is with respect to x. You have your graph, you have your rectangle perpendicular to the x-axis. With respect to y, rectangle perpendicular to the y-axis. Do you understand that? And by rotating all of them at the end, we have the entire figure. Questions? So basically this is an extension of the area below a curve, but with added extra of the pi and the square of the function.
Mr. Bird, aren't you getting like just a little disc and not the whole?
Yeah. A single disk is different. A single disk. But if I were to get all the disks together, I would need to add all of them. Remember?
Integral?
It would be a limit. Sum would be a limit of the sum from it was A to B of that one by f of x squared times delta x. And here it is 1 to n which is But instead of using the Riemann sums, which is this, we use the integral, which is C. Okay? Example. This same example. Calculate the volume of a solid bounded by y equal to square root of x equal to 0, x equal to 4, about the x-axis. That would be the question of this example. So all I need to do, well, you have the graph, have a 3D. What do you do? Simple. The volume is going to be pi times the integral. From where to where? From 0 to 4 of the function. What's the function? Square root of x raised to that square times dx. Solve it. Pi 0 to 4. Square root of x to the square is what? X. Dx. So it's going to be pi x squared over 2, 4 to 0. So it's going to be pi times 8. 8. So the answer is 8 pi units. That's the answer? That will be the answer.
So the answer will always have pi.
Yeah. So you can give me decimals, but I prefer this. It's more exact with the pi. 8 pi units. Units of what? Units of volume. So it could be whatever. 4 centimeters, 2 centimeters, cubic meters, whatever.
And what is
No, the volume of the entire figure. You graph both 2D, 3D.
Mr. And what if we have cosine or sine and we have values with pi over 2 or something like that?
You will have that.
Huh?
You will have pi.
Yes.
Pi is the limit.
And the answer will still have pi?
Yeah.
I think this is enough.
Good. Questions? No, right? Very simple. Okay, let's try an example. Well, let's try the activity. Good. For example, in the activity, they already give you the formula. It says this method, volume equal to pi from A to B, radius, which is the function, to the square times dx, or pi times integral of 1 to b is radius to the square of d1, where the rest is perpendicular to the rotation axis. In this one, first one, it says the region bounded by y equal to x squared, x equal to 2, and the x-axis is rotated about the x-axis. Calculate the volume. Here, the function is x squared. The limits x equal to 2 and the x-axis, and the rotation axis is the x-axis. This is not redundant because sometimes the axis is not the x-axis, sometimes the y-axis, sometimes another axis that is not one of the original ones. And that's going to be different. So here, what do you do first? Just like we did with the areas, we're going to graph. When I told Claudia, we're going to graph two graphs. One in 2D, one in 3D. By hand.
So don't we need another x value?
No, you'll see. For example, what's the graph of x squared?
Parabola.
A parabola. 1, 2, 1, 2, 3, 4. Okay? So in this one, 0, 0, 1, 1, 2, 4. That's the graph. Now, the limits from 0 to 2, that's what it is. In the 2D graph, I need to represent also the rectangle. What rectangle? Could be any rectangle, but it has to be a rectangle like this one. And to say the x and this is going to be f of x. You need to put it. You need to put the rectangle. Because the rectangle represents the radius of the entire figure. So you need to put it. That's in 2D. And you're going to graph also the figure in 3D. Approximately. So, something like this. One, two, 1, 2, 3, 4. 1, 2, 3, 4. Okay? So, for example, here 0, 0, 1, 1, 2, 4. That's the parabola. But since I want to rotate the parabola, also in the other direction. 1, -1, 2, -4. Like this. And then just represent with a little circle. Well, kind of. Like this. Like a little, yeah, like a chord or something. Yeah? You need to show me this also.
Que solo será la mitad de la parábola.
The drawing doesn't specify if it's going to go in the other direction. So in this case, we're going to just say that it goes from the 0 to 2. It has to be a little more specific, yeah. But in this case, it's from 0 to 2. Yeah. No, the reflection is because you're rotating. That's why it's like that. And since it's in 3D, you need to reflect it also. No need to put the z-axis, x and y right now, but show me this, the figure also. Okay? Questions? You can also show me the disc that is formed, which will be the rectangle, rotated. Something like this. This is the x, and the radius, which is.
Entonces, ahí solo está rotando en derecha de la X, ¿verdad?
Yeah. That's what the problem says. If it was y-axis, it would be something different. Good. Questions? Even if it's not exact, I want to say this also. You need to visualize what the figure is going to be. Que tienen problemas en 2D, también tienen que graficar en 3D. ¿No es divertido? Sí, es divertido.
¿Cuál divertido?
Claro, pues todos van para ingeniería, ¿no?
Sofi, ¿no?
Con la mayoría, pues. Digo, con todo respeto, pero si no van para ingeniería, pues, ¿qué hacen aquí?
Fuera.
No, pero Sofía es excepción, porque Sofía es muy buena.
Luego tengo un valor de X, entonces está escrito que es de 0 a eso.
No, hablando en serio, o sea, en ingeniería van a enseñarse todo esto con computadora, como dice yo ahorita, en 3D, pero tienen que aprender a visualizarlo ustedes desde antes. Es parte de ser un buen ingeniero, que lo visualicen. Que lo visualicen. Si no visualizan las cosas, no son buenos ingenieros. Fine. Yeah. Okay. What's the volume then?
Pi from 0 to 2. Integral.
By integral 0 to 2 of what? X squared to the square dx.
Sería ya saltando pasos X a la quinta.
Yeah, you can give some steps and solve it. So pi x to the 5 over 5 from 0 to 2. So the answer is going to be 2 to the 5th power 32 pi over 5 units. Why? Because the 0 will be captured. So. Good. Questions? No?
No.
No?
Fácil, pues regaló a 0 porque decía que estaba en el
That's the initial.
Ajá.
That's the initial one.
Ah, ok.
Yeah.
No hay preguntas.
What? No.
Claro que sí, solamente vea que
The answer is this.
¿Vas a estar reaccionando a la examen?
Yeah.
sí, voy a estar tomando el examen. Tú vas a estar pasando Qué miedo. A ver, ¿quién te va a ayudar? Sofía no va a estar en ingeniería. Nada más te digo. Sofía Simón, en las clases de cálculo. ¿Qué? Hola, no, ¿cómo pasa? Derecho. Sí, sí. Ingeniería en Derecho.
Los metas son de la actividad.
Ajá.
Póngase.
Okay. Now, second exercise says the region bounded by, again, y equal to x squared, y equal to 4, and the y-axis, and the rotation axis is the y-axis. So this time is going to be respect to y. The figure is going to be different.
We need to change the function, no?
So, first into D.
Ya, no.
Mariana se niega a reprobar.
First into D, so the function is going to be the same. 0, 1, 1, 2, 4. But this time it says y equal to 4, so it will be from here to 4, and the rectangle will be what? Vertical? No, horizontal, yeah. Like this. This is the dy, and the height or the radius is f of y. Okay? Where do you put the rectangle? It could be in the middle, it could be wherever you want to put it. Doesn't matter. It just represents the area. That's in 2D. Now in 3D.
¿Por qué decía que no deberíamos dibujar la parábola completa?
Huh?
¿Por qué será 4?
Because of the y-axis.
Pero entonces no debería de ser así. O sea, y al cuadrado. Ah, no. Perdón.
¿No deberíamos de graficar en el y-axis?
No, porque
No.
quieres igual aquí. Si fuera el cuadrado.
¿Y para qué?
Ah,
Okay. Now, the parabola. 0, 0, 1, 1, 2, 4. Yeah.
Nada más, ¿dónde sacamos los límites en la función anterior?
Which limits?
2 y el 0.
From here? Y equal to 0, y equal to 4. This one, 0, 2, 0, 2. So you cannot extend to the other side because it doesn't say that you have another limit
Ah, o sea, el 10 es
on the x-axis. Yeah.
y X es igual a
If you have another limit, I'll specify from x equal to minus 2 to 2 or something. So, that's my parabola. And now, the other parabola, the rotation is going to be not here like that one, it's going to be in the other side. 1, 1, 2, 4. So here. And something like this is going to be the final form. Okay? The disk now is going to be horizontal.
Profe, ¿cómo se fue el dy?
Which dy?
El que sale en la otra imagen.
Is dy?
Ajá.
It's just the height of the rectangle.
Ah, o sea, ¿puede ser donde sea?
Yeah.
Ah,
It's not a specific value, it just represents the height of the rectangle or the width of the disk. Okay? So this is the dy and the radius, that's f of y. Okay? Remember, yeah, what?
No tenemos que hacer ahí como las cosas que deben de despejar hierro.
Yeah, that's the next part. So, if I want to calculate the volume, then the volume is going to be pi integral. It says respect to y, so it's going to be from 0 to 4, but not x squared. What I'm going to do is, since the function with respect to y, I need to isolate it. So, x equal to square root of y. Square root of y to the square times dy. Pi integral 0 to 4 of just y dy. Pi y to the square over 2 from 0 to 4. So the answer is going to be 4 to the square 16 over 2 is 8 pi units because the 0 cancels. Yeah.
Ahí no tenemos que poner más o menos.
No, because the rotation takes care of that. Good. Questions? The inclination of this axis is given by me because it's better to do it like that. But you can do it horizontal. You can put it horizontal. It doesn't matter. Just show me the 3D. Show me the rotation. Like this. Okay. Fine. Okay, right now, please, your notebooks or your activity 5 and 6. Right there, even 5 and 6.
Luego vamos a ver el Washer Method.
Thursday. Wednesday or Thursday?
¿Cuáles son las 5?
5 and 6. Connectivity 5 and 6, but it's not in here. The connectivity is here.
Para mí sí también.
Yeah.
Vamos a hacer graficador.
Hmm?
Graficador.
No.
Graficador.
Yo no me acuerdo de era como
Vamos, parábola.
¿eh?
Vamos.
Ajá, estoy visualizando, pero es que es mucho.
Ah, no, ya hace rato. Si le quieres poner el resultado, creo que es así. Puedo necesitar. Nada más muéstrame que hay una figura.
¿Para qué vas a graficar?
COVID.